Okay, let's take a look at this skill practice activity on naming branched alkenes. As usual, I would like to advise you to pause the video each time when a question comes up, and you try it out before you look at the answer, and then you come back to listen to the answer that I'm giving, and you look at how I'm solving the problem, so that you're practicing more that way instead of just listening passively. You don't tend to engage all your learning tools, which is your visual, auditory, and kinesthetic in this process. That's what we want you to try and do. Use as many of those senses as possible. Right. Let's take a look at the first alkene, which is just a simple one. The rules are, first of all, we identify the longest chain, continuous chain, and the chain must contain the double bond in the case of alkenes. And this one is just a simple alkene which has got a straight chain of 4 carbon atoms, and the prefix for 4 is BUT, which is but. And we have to state the position of the double bond. We do not have any side chains in this one here. I decided to start with a simple one so that we can actually see how it changes as we move forward with a bit more complicated structures. So what we're looking at is I've got 4 carbons, and the prefix is but, and I have to state the position of the double bond, and the position of the double bond I state must be the lowest possible when I number this carbon chain. I could number this carbon chain from here to there, 1 to 4, but what it means is the first carbon that I get to, which is possessing this double bond, is carbon number 3. So that will give us this carbon a locant number of 3. But if I number from this side going that way, the first carbon that I get to, which possesses the double bond, is carbon number 1. So 1 is the lowest possible locant number I can come up with on this one. So I'm going to have 1 as my position of my locant number. Remember, we separate numbers with hyphens, and we separate numbers and letters with hyphens, and if they were numbers, we separate them with commas. So we only have 1 number, no need for a comma. We're just going to use a hyphen in this case. So it's going to be but 1 in. That's the name for this one. Now let's take a look at the next one. This one has got a branch, so I'm going to get rid of this here so that I will have more space and it's much clearer. Right. I look at my longest chain. In this case, again, the longest chain is just a straight chain here. Okay, this hydrogen moved a bit. It should be bonded to this carbon here, just to correct that. Anyway, back to this here. This is my longest chain. It's a just straight one. It doesn't go windy or anything like the complex one we saw when we're looking at the rules for naming alkanes and alkenes. Now we've identified our longest chain. We need to number our carbon atoms so that we have the lowest possible locant number for our double bond. From this side, we'll get a locant number of 1, 2, 3, 4. But if we number from this side, we get a locant number of 2. So we're going to number our carbons from this end going that way. So what we have is, so we have got 1, 2, 3, 4, 5. Our longest chain is 5, so the prefix for this is pent. And we need to state the position of the double bond, which is position number 2, which is pent 2 in. But with this one, we've got side chains, we've got branches there, we've got groups that are not normal hydrogens that we've been seeing in what that we saw in the previous one. So we've got a bromine here and a chlorine and 2 bromine and a chlorine. This bromine is on position 1, and we've got another one on 3. So we've got 1, 3, 1, comma, 3. We separate numbers with commas, dash, di, bromo. And because I've started by naming bromo here because the side chain, because B comes before C, because we're going to name chloro next. So, and also put the prefix di to show that we've got 2 bromine atoms there. Now, in the 2 bromine groups, not atoms, 2 bromine groups in that hydrocarbon. Now, we go on to look at the chloro. Chloro is on position number 4, on carbon number 4, 1, 2, 3, 4. So it's going to be 4 dash chloro, and we bring the parent chain name on there, chloropent 2-ene, right? Okay, this is the name for this one, 1,3-dibromo-4 chloropent 2-ene. Okay, let's take a look at the next one. The next one is another alkene again, which seems to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 going this way. Our longest chain must contain the double bond. Okay, we've got a long chain that goes this way. It has got 6 carbon atoms, but remember we said the longest chain must be the one that contains the double bond. So instead our longest chain is going to be this one here, going this way, because that's where we have the double bond. That's the rule. And we number our carbon atoms to give the double bond the lowest locant number. In this case, we are starting from this end. Obviously, just by simple survey, you can just look at this and see if I start from this end, my double bond will have a locant number of 4, but in this case it has got a locant number of 1. So I've got 1, 2, 3, 4, 5 carbon atoms. So it means my longest chain is as a prefix pent, and we know that the double bond is on carbon 1, so it's 1-ene. That's my parent name for this chain, the main name for this hydrocarbon. And we have got side chains here. So what you do if you're given a displayed formula, just group everything and write it as a molecular formula like C2H5. So C2H5, we know that the prefix for 2 is eth, right? So this one is an ethyl group because it's a side chain, and the suffix for all alkyl groups is YL. This one here, we've got a methyl group right there, right? And when we are naming these, we start with the one that comes first alphabetically. E comes before M. So in this case, the name for this one is going to be 1,2-ethyl, because this ethyl group is on carbon number 2. So it's going to be 2-ethyl dash, and this one is on carbon number 3, 3-methyl pent 1-ene. This is the name for this alkene. Right, let's see what the next one has in store for us. I'll move on to the next alkene, which is this one here. When we're looking at this one, the longest chain possible one is from here all the way up to there. So I've got 1, 2, 3, 4, 5. I've got 5. So it's another pent again. And my carbon, which has got the lowest locant number that contains the double bond, is carbon number 2. So I've got pent 2-ene. Right? Do we have any side chains here or branches? No, this is just the longest continuous chain like that. So there is nothing coming out of it that's not a hydrogen. So the name for that is simple and straightforward, pent 2-ene. Right, let's look at the next one. This one looks a bit windy, so we're going to have to to try all the possibilities. Whatever possibility we try, it must come through this here, because that's where we have our double bond. So if I start counting from this end, I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 going that way. Because why did I pick that one? Because simple inspection is just pretty much telling me that could be the longest chain. If you want now, you can just test the other ones. The other possibility that contains the double bond is 1, 2, 3, 4, 5. If I come this way and that way, then that has got 5. I could also look at this one as a possibility. I can start from here and come round all the way there. So it has got 1, 2, 3, 4, 5, 6, 7. So this chain and that chain are just the same length. I pick whichever I want. It doesn't really matter. It makes no difference. Right. I'm going to pick the first one that I identified, not because it's better, but that's what I identified first. So it got the first dibs on that in terms of which one is going to be picked. Now let's take a look at what we have here. I've got 1, 2, 3, 4, 5, 6, 7, and I need to number these carbons in such a way that my double bond carbon, my double bond has got the lowest possible locant number. So if I number from this end, my double bond position is going to be number 3. If I number from this end, my double bond position is going to be number 4. So I would rather start from this end, right, going that way instead of this one here. We can't use that one now. So to name that, we need also to identify identify and name these side chains or the branches. I've got an ethyl group here because I've got C2H5. This is, if you put this together, it's C2H5. And this one here is an methyl group. Now, having done this, what do I need to do? I need to put the name together. Let me just scribble that out because it's from the previous one. It might confuse you. So this one, 7, it's hept. So my principal name is going to be hept. I'll write it here so that I can hept. And the position of the double bond is 3, hept 3 in. Okay. And I need to add the side chains, and I've got 3 ethyl. And on carbon number 4, I've got a methyl group, 4-methyl heptane. That's the name for this one, 3-ethyl 4-methyl heptane. I've put the side chains in alphabetical order. As you can see, guys, as I'm naming these, I've got an understanding of the rules. So pretty much I'm chunking the rules instead of trying to remember these rules individually. Okay, let's clear this and move on to the next hydrocarbon. If we still have one more, I think, yeah, we still have one more. So looking at this here, we do the same thing again, looking at the longest chain that contains the double bond. It could be this one or it could be the one that goes down, but counting going this way, we've got 1, 2, 3, 4, 5 carbons, and here we've got 1, 2, 3, 4, 5. It doesn't matter which way I go. So I'll take the straight one, the one I went with first, right? And I've got one side chain there, and the lowest possible locant number for the carbon is on carbon number 2, which is, that's the first carbon I get to before I jump over the double bond. So I don't say number 3 because it will be the largest, it will be the highest possible locant number. I need to take this one here because it's the first carbon I get to, which possesses the double bond. Now, this is carbon number 1, that's carbon number 2. So looking at this here, we are saying this one is a pentane, so it's this one is a methyl group, and methyl is on carbon number 4. So for this one, the name is going to be 4-methyl pent 2-ene. Okay, that's the name for that one. I think these are getting a lot better now, hopefully for you, because we've practiced a few. There will be a few more worksheets coming out with some of these for you to work from and practice. Let's see if we've got another one. Yes, we've got another one. Let's first of all clear that so that we are not, it doesn't confuse us as we work through this. The usual order, find the longest chain that contains the double bond, and when I'm looking at it just by simple inspection, this is my longest chain. If you want to double check that, you can count the carbons. So 1, 2, 3, 4, 5, 6. The only other way I could go would be from here all the way up to there, which has got 4 carbons. So my prefix for that is hex, and my double bond is on carbon number 2. And I've got a methyl group on carbon number 3. So the name for that will be 3-methyl. There's no other side chain, so I don't need another dash, so it's hex 2-ene. Okay, so this is the name for this one. Let me see if I've got another one for you. Actually, that brings us to the end of this video, and next up is we're going to be looking at when you are given a name, how do you come up with a formula? This way now you will get an understanding of why it's important to exactly follow those UPAC rules when you are writing the name of a compound, because when you've got the right name, anyone can take that name and reproduce the structure of the compound that you have stated. So I'll see you when you watch the next video.